When we look at radical expressions and we want to simplify, we're really looking at trying to get to a simplified radical form. So if I start with like the square root of 18, it's not a perfect square, but if we look at it, it's the square root of 9 times 2. And then you can say, well, square root of 9 times square root of 2 in separate radicals, square root of 9 we know as 3, and we get to this simplest radical form of 3 root 2. Now there's other ways we can simplify. Sometimes we like to look at factors and find pairs, but the focus is finding this perfect square as a factor and taking it out of the radical. We may have terms left, and that's perfectly fine. We just write it in this form. So for example, we look at 72. A common way we see that is 8 times 9. Well, 8 is 2 times 4. 9 is 3 and 3, and we can go a little bit further on 4 to be 2 and 2. So the factors of 72 are 2, 2, 2, 3, 3. Now when it comes to getting in simplified radical form, we have to take a pair out. I have a pair of 3's and a pair of 2's. These are going to come out of the radical, and what I'm left with is this 2 right here. So 3 times 2 times root 2 we write as 6 root 2. Then we get to something like 2 root 99. Well, 99 is 9 times 11, and 9 becomes 3 and 3, so that 3 comes out along with the 2. The 11 is left inside, and we have 6 root 11. So we then take that and then put in variables. So let's just say I had x squared by itself within the square root. Well, x squared is x times x. A pair of those numbers comes out, so I write that pair on the outside. For the square root of x to the 4th y to the 6th, I have 2 sets of 2 for x to the 4th. So two sets come out. Y to the 6th, I have 3 sets of 2, so y to the 3rd comes out. I don't have anything left, they're all gone, so my answer is x squared y to the 3rd. Now that's going to follow a little bit different end result as something like x to the 5th, y to the 9th. X to the 5th has 2 sets of 2, so that comes out, but it's got 1 left over because x to the 4th is an even, that became x squared, kind of like here. The odd one out is left inside, stays inside the radical. Y to the 9th is the same idea. How many sets of 2 do we have? We have 4. 4 sets of 2 is 8 of them, leaving 1 left over. So we'd write this as x squared y to the 4th, square root of x, y. Now we start putting this together with the numbers and the variables. So 36x to the 4th. 36 is 6 times 6. The 6 comes out. X to the 4th is 2 sets of 2, so I write x squared on the outside. 24 is 4 times 6, and why I picked 4 times 6 is 4 is 2 times 2. That's going to bring a 2 out. The 6 stays inside. Because the 6 is 2 times 3, it's not going to have any perfect squares. X to the 7th has 3 sets of 2, or it has x to the 6th, which makes it x to the 3rd on the outside, and the x stays in. Building upon that a little bit more, we now get to something like 2x times the square root of 48x to the 5th, y to the 3rd. Let's go to 48 first. 16 times 3 is probably the best way to go about the factors, because that takes out a set of 4's. So we're going to have 2x times the 4 coming out. 3 stays inside. X to the 5th is 2 sets of 2. It's an x to the 4th, which is half of it. X squared on the out. 1 stays in. Y to the 3rd brings out 1 set of y's, 1 odd remainder left. So we'd write this now together on the outside to be 8x to the 3rd y square root of 3xy. Our last set now looks at cube root or 3rd root and then a 4th root. It still follows the same idea as a square root, but you're taking a bigger set of numbers out. So for example, 8 is 4 times 2 and 4 is 2 times 2. I have 3 2's here. That's what I need to get out of the radical because it's a third power, or 3rd root. So the 2 comes out. X to the 6th, it's saying how many sets of 3 do you have? Well, if I have 6 x's, there's 2 sets of 3, so x squared gets out. So our answer is 2x squared. We go to something like the cube root of 16, x to the 5th, y to the 9th. This will have something left over because 16 is 4 and 4. Then we have 4 2's. So that's going to take a set of 2's out, 1 left behind. X to the 5th has has one set of 3 that comes out. If I take away that one set of 3, I have 2 x's left over. Y to the 9th has 3 sets of 3's, so we write that as 2xy to the 3rd, then the cube root or the 3rd root of 2x squared. For 40, 40 is 8 times 5, which 8 gets the set of 2's out. 5 stays inside. X to the 7th is going to have 2 sets of 3, because that's 6 of them. 1 remaining, put it there, so we could write this as 2x squared cube root of 5x. Last one is 4th root. 64 is 8 times 8, which is 2 times 4, 2 times 4. I'm just going to rewrite this. I have 6 2's here, so it's the 4th root of 2 to the 6th, x to the 5th, y to the 7th, z to the 9th. If I have 2 to the 6th, that's 1 set comes out. That leaves 2 sets behind, 2 2's behind. X to the 5th takes out 1 set. 1 stays behind because I take out 4 of them. I have 1 left. Y to the 7th takes out 1 set. There's 3 remaining if I took 4. Z to the 9th, I could take out 1 and another set. So if I went z squared, that would be 8 of them. 8 set, to be 2 sets of 4, 2 times 8, leaving 1 left over. So we could write it like this, but we'd also probably see it as 4xy cubed z on the inside, just doing the 4 squared.